All right, today we're peeling back the layers of the Windows operating system. We're going to go way beyond the desktop you see every day and explore the powerful, complex machinery that's running underneath it all, using the exact same tools the experts use. So let's dive right in.
So let me just ask you, what is your computer really doing right now? Yeah, sure, you see your apps, your files, your mouse zipping across the screen, but beneath that surface, there's a whole hidden world. Hundreds of processes, thousands of threads, all constantly talking, managing memory, and interacting with your hardware. It's a place of incredible complexity, and today, we're going exploring.
So here's our expedition map. We'll start by establishing this idea of Windows as a hidden world. Then we'll grab our first tool, Process Explorer, to get our bearings. After that, we're going to check the system's vital signs to see how it's doing overall. And finally, we're going deep, right into the kernel itself. The goal? To turn you into an empowered explorer of your own machine.
Okay, first things first, you have to stop thinking of Windows as just a simple desktop. Instead, picture it as a massive, bustling city, a metropolis that never sleeps. Every single time you click your mouse or launch a program, you're setting off this incredible chain reaction of activity within that city.
You know, most of us, we're basically just tourists in this city. We stick to the well-known streets, the familiar applications. But the tools we're about to cover, they're like the keys to the city. They get you into the back alleys. They show you the building blueprints. They give you an all-access pass to the city's control center. They take you from tourist to true urban explorer.
Our first and maybe most important tool is Process Explorer. So if Windows is our city, think of Process Explorer as an incredibly detailed, high-definition, real-time map of every single street and vehicle.
Now, you're probably familiar with the regular Task Manager, right? And it's fine. It's like one of those simple tourist maps. It shows you the main roads. But Process Explorer is on a whole other level. It's like a military-grade GPS. It doesn't just give you a flat list of processes. It shows you the parent-child relationships in a tree so you can see what launched what. It reveals detailed security information. It unmasks what's hiding inside those generic host processes. The bottom line is this. Task Manager tells you what is running. Process Explorer tells you how and why.
And that depth of information is what really makes it a game changer. You can see a process's entire security token, every group it belongs to, every privilege it has. You can finally solve the mystery of svchos.exe, that generic box that holds so many Windows services. You can even see its security posture, like which extra shields are active to protect it from attack. It's the difference between guessing and truly knowing.
So let's just take that svchost.exe example. In Task Manager, it's just a name. It's a black box. But in Process Explorer, you can just double-click it and boom, you can see it's actually just a container. And inside this particular one, you can see it's running the background intelligent transfer service, the delivery optimization service for Windows updates, and a few others. Instantly, a mysterious process becomes completely clear.
Okay, so we've mapped out the city's streets. Now let's zoom out a bit and check the vital signs of the entire metropolis. We're going from looking at individual cars to monitoring the flow of traffic, the power grid, the overall health of the entire system.
And just how deep can we go here? Get this. Windows exposes over 700 different system parameters that you can monitor in real time. That is a staggering amount of diagnostic data, measuring literally everything from your physical hardware to the deepest corners of the kernel.
The tool for this job is the Performance Monitor, or as most people call it, PerfMon. You can think of it as the ultimate diagnostic dashboard, or an EKG for your operating system. It's been part of Windows for decades, and it gives you the power to track all of those hundreds of performance counters to figure out bottlenecks and really understand system behavior. So what kind of vitals are we talking about? Well, you can see the exact state a specific thread is in. You can monitor the kernel's private memory pools. This is special memory that's reserved only for the Core OS. You could even track really low-level stuff like contact switches per second. And that one's huge, because if that number is through the roof, it can explain why your whole system feels sluggish. The CPU is spending more time just juggling tasks than actually doing them. This is like putting a stethoscope right on the heart of your processor.
We've seen the processes, and we've checked the system's pulse. Now, it's time for the final leg of our expedition. We're going to the very core of the city, the central command of the entire Windows operating system, the kernel.
But hold on. Before we can look inside the kernel, we need a translator. See, the kernel speaks in raw machine code and memory addresses. To make sense of any of it, we need what are called symbol files. Just think of symbols as a map or a dictionary. They connect a raw address, like 0xFFF80280A180, to a meaningful name, like current PRCB. Without symbols, trying to understand the kernel would be basically impossible.
The tool for this really deep dive is the Windows Debugger, or WinDBG. Now, this is the official tool. It's what Microsoft engineers use to debug the OS itself. It lets us literally pause the entire system and inspect the kernel's internal data structures using special commands that start with an exclamation point, famously known as bang commands.
So for example, you could run the bang command /process00. What you're doing there is asking the debugger for information on core system processes. And it'll come back with the raw memory address of the process object, its session ID, its image name. This is how an analyst might start digging into a system crash or some kind of suspicious activity by talking directly to the kernel.
Now, I know it sounds incredibly complex, but the process itself can be broken down into a few key steps. First, you have to boot Windows into a special debugging mode. Then, you have to tell the debugger where to find those critical symbol files. After that, you're free to execute commands and start analyzing the kernel's live internal state. It's an incredibly powerful capability. So we've made the journey from the surface all the way down to the core. Armed with these tools, you're no longer just a user of your operating system. You are an explorer, and you are equipped with the keys to truly understand it.
And here's the most important takeaway. Process Explorer, Performance Monitor, and the Windows Debugger aren't just for developers or security researchers. They're powerful instruments for anyone who's curious and wants to really know what their computer is doing. They make the massive, invisible world inside your machine visible and understandable.
You now have the map to the city, the monitor for its vital signs, and the keys to its very core. So the only question left is, what part of this hidden world are you going to explore first?
Help me out, please smash that like button, leave a random comment and subscribe if you want to become a better hacker.